Objective 5, solve quadratic equations by completing the square. In this video, I'm going to do two different examples, and then I'll have you try two similar examples on your own to check your understanding. Now, please keep in mind, within this objective, solve quadratic by completing the square, you're going to get a standard form quadratic equation to look like vertex form of a quadratic equation, if you remember from Module 2. And then from vertex form, you're going to solve by taking the square root of both sides, and that's step 4. All right, so step 3 will look like vertex form, so let's make a note of that. And then step 4 is taking the square root of both sides. All right, steps 1 and 2 I've listed out as well, and that just displays my thinking, so please follow along and label your steps as I do as well. So the first step, if I was to solve number 1, is to kick the C term to the other side, or just move the C term over to the right-hand side. All right, so if I were to do that, it's a positive 8, so I'm going to subtract 8 from both sides. And that it's supposed to be step 1. I will circle there. So this is step 1. Now, in that case, now I have a squared minus 6a. I'm going to leave a little space between my b term and the equal sign to complete step 2 next, so I'm going to put equals negative 8. Instead of a positive, it can be negative 8 on the other side. Now, that's step 1. Done with step 1. Step 2 says to complete the square by adding this formula, the b term divided by 2 squared. Otherwise, half of the b term raised to the power of 2 is another way you can say that. I'm going to add that to both sides. I'm going to do step 2 in the green color. So I'm going to add, that's why I asked you to give a little bit of space. Add, my b term in this case is negative 6 over 2 squared. And I'm going to add that to both sides. Negative 6 over 2 squared. And eventually that's going to work out to a number. Now, to finish step 2, I'm going to actually write my new equation. I have a squared minus 6a. Now this math, negative 6 divided by 2 is negative 3. Square that is a positive 9. So technically I'm adding 9 to both sides. Half the b term squared in this case is 9. Equals negative 8 plus 9 is 1. A positive 1. So from that, all I did, I changed this piece to 9. This piece was 9. Negative 8 plus 9 is 1. That's how I got that 9 there and that 1 there. All right? Now, step 3 says to factor the perfect trinomial on the left-hand side. What that means, I will show that work down here. A squared minus 6a plus 9. So it's going to look something like this. All right, it's going to break down to a perfect square binomial. All right, it's a perfect square trinomial, so it's going to break down to a binomial, squared. So I know that a squared is a perfect square because I can take the square root of it and just get a. And then I know that it's going to be minus, because the b term is negative in this case. If the b term was positive, then it would be plus. So it's going to be a minus something. And in this case, it's going to minus half of whatever the b term was again. All right, so in this case, the b term was 6, so half of that is 3. So it's going to be a minus 3 squared on the left-hand side now. So this whole thing becomes a minus 3 squared. Now the math behind that, if I were to expand that back out and multiply a minus 3 times a minus 3, you would get a squared minus 3a minus 3a plus 9. And then to finalize that, you get a squared minus 6a plus 9. It goes back to the original function on the left-hand side, but I want to write it in vertex form. All right, so I got it done in the vertex form. A minus 3 squared equals 1. that was step 3. Factor the perfect trinomial and get it into vertex form. Now, step 4 then just says to, I'll use blue again. So I just did step 3. Step 4 says solve by taking the square root of both sides. So step 4, I'm going to write right here. I'm going to rewrite everything just to show you what I'm doing. Minus 3 squared equals 1. Now, to get rid of the power of 2, I have to take the square root of both sides. Because the square root and the power of 2 are inverses of each other, meaning they cancel each other out. So I'm left with a minus 3 on the left-hand side equals, when I take the square root, the action of taking the square root of a number means that I have the positive version of the answer and the negative version of the answer. So now I have the square root of 1 is positive 1 and negative 1. If you notice now, all I have to do to solve for A, to finalize everything, is to add 3 to both sides. But in this case, the right-hand side has 2 numbers to add 3 to, a positive 1 and a negative 1. So A is going to equal 2 solutions, and hopefully you recognize that because it's a quadratic, meaning it is the highest power of 2. So we're looking for 2 solutions, and in this case, those 3's cancel out on the left-hand side. Positive 1 plus 3 is a 4, and a negative 1 plus 3 is 2. So my 2 solutions to this quadratic trinomial equation up here is positive 4 and 2, and that is how you solve by completing the square. Go ahead and try number 2 on your own. Remember, you kick the c term out, you complete the square by adding half the b squared to both sides, and then step 3 is you factor the trinomial to get it to look like vertex form. So something like this. Step 3, get it to vertex form. And then you solve by taking the square root. Please pause and try number 2 on your own. You should have paused the video and tried number 2 on your own. The solutions I got were m equals 2 and negative 6. If you did not get that, please check with a neighbor or raise your hand and I will come check your work. Now, really quickly to finish off this video, I wanted to do one more example because you'll see this as well. If you notice, the a term in this case is not 1, where the a term in the first example and number 2 that you did was 1. So whenever the a term is not 1, the first step you have to do before you do all the other steps that we just practiced is divide each term by whatever the a term is. In this case, it's 3. So divide each term by 3 to get a new function where the a term is 1, because we like working when the a term is 1. So in this case, 3 divided by 3 is 1, so now I have p squared plus 4p plus 12 equals 0. Anything 0 divided by anything is still 0. Now, we got it into the format we want, where the a term is 1. In this case, we can just start from the beginning of these 4 steps up here, and I'm going to do the first step first, kick the c term to the other side. So minus 12, minus 12. So my first step is now going to be p squared plus 4p, leave some space between that and the equal sign, equals negative 12 now. The second step is going to be adding b squared, or I'm sorry, b over 2. In this case, it's this b, not this b, because we went to this function. So it's 4 over 2 squared, half of b squared to both sides, 4 over 2 squared. So that leaves me with p squared plus 4p plus 4 divided by 2 is 2, squared is 4, equals negative 12 plus 4 is negative 8. So far, so good. Now I have to get it into vertex form in step 3. So in this case, it's p. The b term is positive, so I put plus. And then half of the b term in this case is 2. And I'm going to square that binomial. Equals negative 8. Then the fourth step is to take the square root of both sides. I'll rewrite it though just to show my work. I take the square root of both sides to cancel out the power of 2. Now if you notice, we're taking the square root of a negative. Keep that in mind. So I have p plus 2 left over. equals 8 is not a perfect square. We've been working with perfect squares before, so I have to break down 8 into 4 and 2, and then 2 and 2. Erase that. So a pair of 2's comes out, a 2 is left over because it didn't have a pair. So let me rewrite what's on the left-hand side. P plus 2 equals the positive version of 2, I need to put an I because I'm taking the square root of a negative, so 2I radical 2, and the negative version of that, because again we're taking the square root, so I have a positive and negative of the same answer, 2I radical 2. And to finish it off then, I add 2 to every, subtract 2 from the left-hand side to every piece. So that cancels out over here. So P is going to equal 2 complex conjugate solutions. I'm going to rewrite this whole piece with the real term coming first, minus 2 or negative 2, plus 2I radical 2, and then this whole piece with the real term coming first, negative 2 minus, it's minus right there, 2I radical 2. So if you see my two solutions in this case are complex because they have a real part and an imaginary part. And we're done. Go ahead and pause the video and try the second one on your own to check your understanding. You should pause the video and try number 8 on your own. There are the steps that I've shown, steps 1 through 4, and I got the answers r equals 1 plus 2I and 1 minus 2I. Please raise your hand if your work and your answers do not look like mine. Thank you.